Hello everyone, my name is Maxim. I'm a programmer and trading bot developer, and also I'm a teacher at HFT Crypto API. So in this video, I show you how to make real-time trading bot. So the video consists of two parts. So in the first one, I show you how to organize the backtesting system, how to organize your idea, how to measure profit, etc. And in the second one, I show you how to make real-time trading bot by itself, how to connect it to BitMart exchange. So here, you see the result of our backtesting. Our strategy is based on the combination of two indicators, BollingerBand and RSI. So BollingerBands looks like channel. Here's the upper band, here's the lower. And price usually moves between these bands. And when price touches upper band or crosses it, we can assume that market is overbought. And probably the price will return to this moving average. And vice versa if the price crosses this bottom line, bottom band. We can make long position, probably because the price will also rise up to return to the middle. So it's kind of slow indicator. Sometimes it's not relevant to market in the moment. So we will combine it with another indicator. RSI looks like that. This is oscillator. Its value floats between this extrema, between 0 and 100, and we can assume that if the price above 70, then the market is overvalued. So in this case, the price should fall down. And if the price is below 30, we can assume that the market is undervalued and the price should go up. And look, this is combination. We combine these two signals and get more precise trading system. So higher quality signal. Let's go and make backtestings for that idea. So first we declare all necessary requirements. This one is HFT Crypto API. So from here, we will take the BitMart client to connect to BitMart exchange. This is Pandas. This is popular framework to work with bit data, to process bit data, to do some calculations, and so on. From this library, TA, we will take all the necessary technical analysis indicators, like BollingerBand and RSI. And this one, matplotlib, we will use to plot and chart our results of backtesting. So let's go. First we declare imports from BitMart client, and also all the necessary classificators and structures. We declare datetime, time delta, to work with data. We import pandas with lspd. And we also import some types to use it in our code. First, let's create variable client. Initialize with BitMart client. Let's create symbol. In our case, it's BTC USDT. Because it's most liquid, it's very good for technical analysis. Here we declare time range to export candles back as data. So now, it means now. This moment. And from time, we subtract from current moment 30 days back, 30 days before. So 30 days is testing data. We use method getSymbolKline to get candles from BitMart client. We pass symbol, pass market type. In our case, it's futures. We will work with 1 hour candles. And here, we also pass range of data. So let's look at how it works. As a result, we get a list of k-line objects. It's not really good to insert such data in pandas data frame. So I created this function. It's accept list of k-lines and return data frame with table view data. So first, we map each keyline to dictionary with columns timestamp, open, high, low, close. And then we create data frame. So we pass to the data frame constructor, data, and column names. Also, we use function setIndex to convert timestamp column to table index. And in place means that we will do that in the same variable, data frame. So what is data frame? We can say that it's like table. For example, the Excel table. It contains rows, columns. So we can work like usually we work with Excel tables. So let's look at that. Here is timestamp and 4 columns. So much is good. Let's import indicators. Here we import RSI function. Here we import BollingerBands object. We declare 2 constants, BollingerBand window and RSI window, and create one method to add indicator columns to our data frame. So it accepts our data frame and our constants. Here we add to our data frame one column named RSI and fill it with RSI calculated values. Here we create one BollingerBand object and use such methods BollingerBand high band, Bollinger low band to fill our columns BB upper, BB lower, also with data of BollingerBand. So let's take a look first. You see here's data. Here's nonce because of window. So before 20 candles, it's impossible to calculate, for example, BollingerBand because it's used 20 candles before in our case. So this data is not relevant, we don't need this, and we will drop it with simple function drop NA, also pass in place, to do all the work here. You see it disappears. Okay. Let's plot. So here, we pick only these columns, close, BB upper, BB lower, and plot. Okay. You see the chart. Here's upper band, here's lower band, price. Okay, so far so good. Let's add something else. Okay, we also need to represent our RSI indicator. To achieve that, we need to add one more subplot. To do that, first we import matplotlib pyplot and generate figure with axes based on params. The first param is number of rows in our figure. Figure literally, we can treat like page. So we tell the plot of titles, and so on. So here, we make 2 rows, 1 column. And x-axis is common for bots, or bot subplots. And we specify here ratios between our subplots. Plot with BollingerBands will be 5 times larger than plot with RSI. We do all the same, but only we pass there our axis. Axis with 0 index means that we will plot on the first chart. And we plot the same way RSI on the second chart. So 1 means second. So in programming, all starts from 0, not from 1. So we will attach label and show legend to label appears on our chart. And we hide axis values from the first chart to prevent mess. And maybe first, let's take a look at that. Here it is. Here's another one RSI chart. Okay. So next, we will show entry points. So we literally show our signals. I created 2 functions. One for buy signals, so it accepts series. Series means that it can be row or column of our data frame. In our case, it's row, because we return by rows. So if in our data table row RSI is below 30 and price is below lower band, then we should buy. So we return true, we should buy. And the same if the RSI is above 70 and close to the upper band. So we should sell. So let's create 2 columns, buy signal, sell signal, and apply literating by each row. These functions. So axis 1 means we apply 2 rows, because axis 0 means applying 2 columns. And here, we just filter only values with buy signals and sell signals. So we pass, and this should return true. So literally, that means select all columns where buy signal is true or buy signal is false, and we will plot it on first plot. We call method scatter on the first plot. And we pass index as axis values. So it's timestamp, and we pass close as axis value, so it's price. We show point as marker. Marker, this is magic symbol. That means we should show it as triangle up with green color. Here, we're doing the same for sell signals, but we pass magic symbol V. That means we show it like triangle down. So let's take a look. Okay, now you see that on the price chart, there are a lot of triangles. That all buy signals, sell signals, buy signals, sell signals. So far so good. We already can understand something. Some behavior of our strategy. Let's move on. So in this road, we will iterate row by row and simulate our trading activity. So to do that, first I'll create the list of dictionaries. Here we will record all the trades to use it in statistics after. Here we store our position side, long or short. At the moment, here we store entry price, price of opening trades. Let's wrap it to 2 methods. So open means that we open side position. Position, long or short. It is classifier for BitMart API from HFT Crypto API library, and also price. So to get access to our variables, we use global. And just assign such values to our global variables. In close method, we pass price and closing time, and also we work with our global variables. We just reset it because position is closed, and we make record for trades. So we pass open price, close price, trade side, and also close time. So here we will go one by one each row. but it's not really relevant to iterate through the all rows. So we just pick up only rows with signal. So that means we pick up only rows where buy signal or sell signals appear. That significantly reduces our dataset size. And this means that we iterate by rows. Here should be index, so timestamp, and here is row, series that contains all data. So if we get buy signal and entry side, that means we're not in long position. So if we're not in position at all, we call open. So it assigned to this and this values, long and price. If we were in short position, not in long, then we would close. Call this method and make record about trade. And reset position. Here the same for sell signal. If we get sell signal, we're not in short. If we're not in position, open short. If in position, literally close long. So let's look at trades first. Okay, as you see, this is list of dictionaries. So here is all the data. So to work with data easily, we also use data frames. So we convert such data in data frames, set index close time, and you get this beautiful table with open price, close price, and the direction of trades. Okay, let's calculate the profit next from this data. So I did one function, get profit. It accepts side, open price, and close price, and if side is short. If we were in short position, we subtract from open price, close price, and divide by open price. Then we multiply by 100 to get % profit value. And the same we do for the long position. So we subtract from close open price, divide by close, and so on. And then we apply to our trades data frame this function, also iterating by rows, and get profits. Let's take a look. So as you see, it's kind of good profits. It's kind of inspiring, because we get only 2 losses, small losses, and very big profits. So this is really good result. So let's plot it. To achieve that, we apply to column profit COMSUM. So this function calculates sum. Summary of all previous rows. So for here, it's gonna be this profit plus this profit, and so on. So let's plot and take a look. So it's curve, and it's rising. It's very inspiring, very good. And we also use data frame to print summaries. So first, we can get trades count and just length of our trades. Then we can get total profit. With this function sum applying to profit. Also, we can get the best trade. So it's max profit. And this is worst trade. So it's maximum stop loss. Minimal value of profit. So in our case, this is loss. And this is just average profit for per 1 trades. So take a look. This kind expiring 13% per 1 month for 8 trades. This is the best trade. This is minimal profit. But anyway, we can use some techniques, maybe stop loss or something, to cut losses that reduce your effectiveness. This is average, 1.6%. It's kind of effective, because on BitMart we can also use leverage and boost all the results. So far so good. Our backtesting is completed. If you want to get more details about that, you can go to HFT Crypto API and take full courses, for example. So let's go to the second part of our video and make real-time trading bot. So first, I move all these functions to utils files, because we will reuse the same functions in our bot. So we need data frame, indicators, these two conditions, profit. And let's take a look at our bot. Here we also import BitMart client, import pandas, utils, types, and all already used in backtest functions. And also, we import from config all necessary configs to get access to BitMart private API. So to put orders, get positions, and so on. So here's API key, secret key, memo. Okay. So our trading bot is object. So here's the class, trading bot. In constructor, we pass symbol, we pass contract size. Here we initialize our BitMart client, API secret memo keys. Here we will store our candles and indicators as well. So let me switch to another ADA. I mostly prefer PyCharm. It's kind of better to me. So I use Visual Studio to get access to Jupyter notebooks. So here is contract size. Here we store our position at the moment. And this is profit counter. So we will increase this value, this variable, with each profit from each trade. So first we declare method preload. Here we load our candles, all candles, and append all indicators to that. So actually, we don't really need very long data. We just need the length of Bollinger Band window, plus one candle. So it's enough to get representative value of our indicators. So it's not so hard function. Not so heavy. So we can reuse it many times. So here, we call the same method of BitMart client. Get candles, apply our indicators, so it's gonna be clear. Then we have two methods start. Here we preload data, of course, and here we subscribe to BitMart socket events. So as market we pass futures, here we pass our symbols. In our case it's one symbol, BTC, USDT. And here we use this enum to get keyline 1 hour socket events. And here is subscribe to one private WebSocket channel that updates our position. And here we start WebSocket listening. And this function, this method is listener. So when some event occurs in the WebSocket, some data received, the BitMart client should call this one, and our message should be one of them, either keyline or position change. So if type of message is keyline, we make our trade decision. So here is our bot logic. And if our last candle is before the candle that we get from socket, we just call preload data. So in our case, it's okay, for example, in our example. Maybe it's good not to take all the candles every time. From rest to avoid load. To reduce usage of rest methods. It's maybe not super slow, not as HFT, but for our case it's okay, because we just take it one time per hour. Here we just print position change. So we show open price, position size, and if position size is 0, that means position is closed. So we calculate profit. So we pass to our function getProfit. Position type, either long or short. We pass open price, we pass close price, and getProfit here. So we print position closed, and how much we get from that, and summarize it with profit counter. So far so good. Everything seems to be clear. This method is called stop. Just print our total profit and stop WebSockets. So here we subscribe, and here we process our data. And get decision what we do. So either we should buy or sell. So this means that we take only last row, because we don't need other rows. We need only last one. Here's little printing, just for the bug. RSI, upper band, price, lower band. And if we should buy same method as we used in backtesting, and the position is not in long, then if we're not in position, we open long. If we are in position, we close. In our case, it's short. Close short. The same for sell. If we should sell, and we're not in short at the moment, not in open position, if no position at all, we open short. Otherwise, we close long. Let's take a look at open-close methods, because they make trades. So we print direction. Position type. The BitMart allows to hold short and long positions at the same time. So we can hold two positions at the moment. Because there are 4 types of orders for futures. You can open long or open short. So long we open by buying contracts. Short by selling. Else is to meet sell close long. buy close short. So we call method submit order. Here we pass our symbol. Here we pass market type. There are futures. Here we pass order type, so we will use market orders. Also, it's good idea to use limit orders. It can increase profits. So this is good for use in some cases, some strategies. For example, to catch peaks, or something like that. We use only market to simplify all the process. Here we pass contract size, and here we pass what kind of futures we use. So I prefer cross, and here we also pass order side. Open long or sell short. It depends on the side. Store this value here, in position side variable. And close looks similar, but only if the current position is long, we call sell close. If it's short, we call buy close. And do exactly the same. So we just place market order and reset the position. So much is on. Short brief. We preload data. We preload it before starting. And also when we get one more candle. When position closed, we calculate profit. And we close it when we get some signal. So let's start and look. So starting bot, press any key to exit. So here I create bot. And initialize the trading bot object, start. And this condition is waiting for any key to stop the bot and show the profit. So as you see, it prints our indication values here. Because candle is updating very often. I don't remember, but several times per second. So then this value will be changed. Now RSI is 43. It's kind of far from our bounds. This is, by the way, is close to lower band. So maybe when RSI grows up to 70, and here something changes, then we got a trade. Get market sell order. Maybe after I showed you the result, we finish our listening. Thank you for attention. If you want to get more information, you can get it from HFT Crypto API full course. I wish you happy coding. I wish you big profits. So, bye-bye.